Hello, pre-calculus, welcome back. In this video, we're going to talk about reference angles. A reference angle is an angle in between 0 and pi over 2. And I'm going to show you this picture in your textbook and try to mark it up a little bit and give you a little bit of more of an understanding of what that means. So here we have this understanding that the reference angle is in between 0 and 90 degrees. So what that means is that we can only have a reference angle can only be in the first quadrant. It's only in between 0 and 90 degrees or 0 and pi over 2 in radians. So it's only in that first quadrant. And what a reference angle is it's an angle that you can use to find out information that you need, and it kind of tells you a little bit more about what you're working with. So see this angle they're giving us T here. This angle they're giving us of T, so they're saying that the initial side is the x-axis and the terminal side here, and then I have this angle that's greater than 90 degrees. Goes all the way here. So we have that angle in blue. So what the reference angle that they're talking about here is an angle in between 0 and 90 that's related to this angle. So what I want you to look at is this. I'm going to highlight in yellow this piece of, imagine we're cutting this circle into pieces of pizza. So I'm going to highlight in yellow, that's one of our pieces in pizza. And I'm going to highlight in blue another one of our slices of pizza. And I want you to take a look at those two slices. Are they the same size? Absolutely, yes, they are. These are the same size slices of pizza. And that's a little bit of the idea of what a reference angle is. This angle that I've highlighted in blue is the same size as the angle that I've kind of highlighted in yellow, but it's in a different orientation. It's in the second quadrant. I'm going to go ahead and do the same with the third quadrant example here. So in the third quadrant, here's the reference angle highlighted in blue. And here's how they're calculating it. Those are the same size slice of pizza. Same thing in quadrant 4. Here's my yellow slice of pizza. And my blue slice of pizza. Right? And there is a method to this madness. There's a reason why you care about reference angles. It makes some calculations easier. So we're going to need to be able to find reference angles, and we actually are able to do it following these formulas that they give us here in the textbook. So if you look at quadrant 1, any angle in quadrant 1 is automatically its own reference angle. Its own reference angle. So if I said, what's the reference angle for 30 degrees? You'd say, Sarah, it's 30 degrees. That's already an angle in the first quadrant. When I have an angle that's in the second quadrant, here's how I can find my reference angle. I take pi and I subtract the angle I'm working with here. So what I'm doing is I take the full distance of pi, that angle, and then I subtract, I'll do it in red, the angle t. So when I subtract the red from the blue, what I'm left with is that slice of pizza pie we were talking about, that reference angle size. When I'm in quadrant 3, I take t and I subtract pi. I take t and I subtract pi. So I start with my angle t all the way here, and then I subtract from that an angle of pi. And what's left over is that beautiful reference angle. I hope this visualization is helpful for you. It's helpful for me to think of it this way. And then when I'm in quadrant 4, I take the entire full circle, 2 pi, and I subtract from that t. So I take my full angle of 2 pi, and I subtract from that my angle of t. And the only thing left over is that nice little slice of pizza pie right there. And that's how I'm going to calculate reference angles. I think it would help us to do a couple of examples. So I'm going to do an example for you guys here, just so we can figure that out. Let's say find a reference angle for 225 degrees. So notice that there's different rules depending on what quadrant our angle is in. If it's in quadrant 1, we do something. Quadrant 2, we do something else. Quadrant 3, we do something else. So our first step is to figure out what quadrant this is in. So quadrant 1, that goes from 0 to 90 degrees, or 0 to pi over 2 radians. So this is not in quadrant 1. Quadrant 2 goes from 90 degrees to 180 degrees, or it goes from pi over 2 to pi radians, and this is not in quadrant 2. Quadrant 3 goes from 180 degrees to 270 degrees, or from pi to 3 pi over 2 radians. And I can see, oh, you know what? 225, that fits in here. So this is in quadrant 3. So that's the way I'm going to know what formula to use to find my reference angle. I also want to show you quadrant 4 because I think it's helpful for your notes if you guys can have in this. Quadrant 4 goes from 270 degrees to 360 degrees, or from 3 pi over 2 radians to 2 pi radians. I would copy down these quadrant measurements into your notes for a little bit of practice, especially because I know you guys, the radians, it's going to take a little bit of practice to start to know how to work with the radians really quickly. But radians are much more common in math. We're going to use them a lot more often. So I want you to really put the practice in now. So this is in quadrant 3. Our angle 225 is in quadrant 3. So let's take a look here. And quadrant 3, my formula tells me if I take my angle and I subtract 180, that should give me my reference angle. So I'm going to take our angle of 225 and I'm going to subtract pi, or 180 degrees. And so when I do that, I get 45-degree angle. So my reference angle is 200. I'm sorry, my reference angle is 45 degrees. And that would be our reference angle there. I want to do one in radians just to show you guys how I kind of work that out. We're going to use this example in a minute to do something cool. So here's an example with radians. Let's find a reference angle. For this measure of radians, for 5 pi over 3 radians. Now I know you guys are sweating. You see that fraction and you start to panic. Don't panic. All first we have to do is we have to figure out what quadrant's in, and then we can follow the formula. So I'm going to look at my quadrant measurements here. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I have these different end points. So between 0 and pi over 2, quadrant 1. Between pi over 2 and pi is quadrant 2. Between pi and 3 pi over 2 is quadrant 3. And between 3 pi over 2 and 2 pi is quadrant 4. But it's a little bit hard to have an intuitive sense of where these are. So I want to know, where does 5 pi over 3 fit? Does it fit in 0 to pi over 2? Does it fit in pi over 2 to pi? Does it fit from pi to 3 pi over 2? Does it fit in 3 pi over 2 to 2 pi? So one thing that can help is I need to use common denominators to help me compare. So I see that my denominator here is 3. And these are all my quadrants. This is quadrant 1, 2, 3, and 4. I'm going to give all of these a common denominator of 3 so that I can compare a little bit better. So here, that'll give me 0, and I'll multiply by 3 over 3. I'm actually multiplying this 0 by 3 over 3 as well, but it doesn't matter because it's 0. So I end up with 0 to 3 pi. Oh, sorry. I messed that up. Give me a second, guys. It's been a long day. So what I want to do is I want to be able to understand this is 5 pi over 3. So I want to look at this, and I'm first going to write this as instead of as an improper fraction, I'm going to write it as a mixed number so that I have a better understanding. So this would be 1 and 2/3 pi. So I know this is bigger than 1 pi. So it can't be in quadrant 1. It can't be in quadrant 2 because it's bigger than 1 pi. But at the same time, I see that that's smaller than 2 pi. So it's bigger than 1 pi, smaller than 2 pi. That's a great place for us to be in. We need to figure out which it's in quadrant 3 or in quadrant 4. So what we really know, we know it's bigger than pi, so it could be in either one of those quadrants. What we want to figure out is it actually bigger than 3 pi over 2? If it's bigger than 3 pi over 2, then we'll know that it's in quadrant 4. So I'm going to try to compare 5 pi over 3 and 3 pi over 2. So I'm actually going to give these a common denominator. I'm looking at 3 pi over 2 and 5 pi over 3. And I just want to know which one's bigger. So I'm going to give them a common denominator. I'm going to multiply by 3 and 3 and by 2 and by 2. That'll give me 9 pi over 6. And that'll give me 10 pi over 6. So now it's easier for me to say, you know what, this one's bigger. That means this one's bigger. So that means that 5 pi over 2 is larger than 3 pi over 2, which means we're in quadrant 4. I'll do another example like that in class. I think you guys might have some questions about it, but once you get used to this method, it can really help you if you feel stuck. So I know that I'm in quadrant 4, and so that means I'm going to have to follow my quadrant 4 rule, which says take 2 pi and subtract t. So I have to take 2 pi and subtract my angle. So I'm going to take 2 pi and subtract from that 5 pi over 3, and that should give me my reference angle. Because I'm working with fractions, I need a common denominator. So I can view this as 2 pi over 1. And I'm going to multiply by 3 over 3. So then I get 6 pi over 3 minus 5 pi over 3. And that'll give me just 1 pi over 3. And that would be my reference angle here. Great work, guys. So we can actually use reference angles to help us find values of sine and cosine. So what is the point of reference angles? I'll show you. So I'm going to show you in class how to make your own unit circle, how to construct it, how to find those values yourself. It's going to be really interesting, really fun. But let's have a unit circle. I'll sketch us a beautiful little unit circle right here. And so we have here, 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 here. So this is our unit circle, and I'm going to fill in some common angles and their coordinates for you. So this angle here is 30 degrees. This is also known as pi over 6. And these coordinates here are the square root of 3 over 2, comma, 1/2. This angle here is 45 degrees. That's also known as pi over 4. And our coordinates here are the square root of 2 divided by 2 and the square root of 2 divided by 2. This angle here that we're working with is 60 degrees. And the coordinates here are 1/2, comma, square root of 3 over 2. So if you remember from the last video, these coordinates are actually important. They can tell us sine, cosine, and those are some things we're interested in. So if I asked you guys, for example, to tell me what's the cosine of pi over 3? Well, you would look at our angle, pi over 3, which is 60 degrees. And so you'd say, okay, here's pi over 3, 60 degrees. Cosine is like the x value of this point. So the cosine will be 1/2. And that's how you can find the cosine of pi over 3. Sorry about that. It turns out that we can actually, knowing just what I've shown you of the unit circle, we could actually calculate the values of some of these angles over here in like the fourth quadrant. We can use what we know about the first quadrant and reference angles to calculate values there. So let me show you how that works. So first I want you to think a little bit about the x and y values on your regular graph. So we're going to have our beautiful unit circle, don't worry. And I know it's a little bit off-center. It's bothering me too, guys. Hang in there. One day my art skills will improve. But I want you to just think about x and y values. So these is where I'm highlighting in green, that's where positive x values are. And where I'm highlighting in green, that's where positive y values are. So all points in this first quadrant, x and y are both positive. Then I'm going to highlight in red. This is where all our negative values for x are, all the negative numbers. This is where all the negative values for y are, negative numbers. So if I look at my second quadrant, I see here that all of my x's will be negative and all of my y's will be positive. And let's go ahead and fill that in for each. And then in my first quadrant, my x's and my y's will all be positive. And in my third quadrant, both my x and y will be negative. And in my fourth quadrant, my x will be positive and my y will be negative. So take a second and convince yourself of this, that this is indeed what happens in our graph. Now we know some things about sine and cosine, because sine of t has something to do with the y value, and cosine of t has something to do with the x value. So looking at this picture, I know that if my cosine is if I'm taking the cosine of an angle in the first quadrant, my x in the first quadrant is positive, so my cosine will be positive. If I'm taking the cosine of an angle in the third quadrant over here, my x is positive, so my cosine will be positive. That's going to come up when we use our reference angles here in a second. So it turns out that except for sine, your cosine values, you can use reference angles to calculate them. Let me show you how that works. So let's take, for example, let's say I want you to find the cosine of 5 pi over 3. So first you find the reference angle, which we did in the last step. Find reference angle. Our reference angle here was pi over 3. And then 2, the cosine of 5 pi over 3 is in the fourth quadrant, so I know that that's going to be equal to the same thing as the cosine of pi over 3, which is 1/2. 1/2. And that's going to have a positive value. Let's do an example that works out differently. So let's suppose we have the angle 315. Oh, not 315, excuse me. 180 plus 45. 225. And I want to know what's the cosine of 225. So this is in degrees, and we're going to find the reference angle there. And it turns out that we're in quadrant 3. So in quadrant 3, my formula tells me take 225, subtract 180. And that's going to give me 45 degrees. So that's our reference angle. And we're going to look at the cosine of 45 degrees. So we can use our unit circle. We can say, from our previous example, here's 45 degrees. So I'm looking at the x value here, square root of 2 over 2. So the cosine of 45 degrees is the square root of 2 over 2. But if I were actually looking at this angle, 225, where it would really be is all the way over here in quadrant 3. And so I see that in quadrant 3, my x and my y values are both negative. So when I try to find the cosine of 225, the cosine of 225 will be negative square root of 2 divided by 2. I hope those were helpful examples. It might take you some practice. You might take you reading the book a little bit before you fully get this. Hang in there. Stay safe. Keep practicing. And you guys are going to be just fine. All right, I'll see you in the next one.